Right, hello everyone. So today we're going to be going over our workshop on iOS app development in Swift, the Swift programming language. So let's take a look at what we're going to be going over today. So we'll start off with an intro to app development in general. So what it is and why learn it, like some special niche characteristics of it. We'll walk into Xcode, which is the IDE where you're going to be kind of writing your code and doing all the app development itself, kind of showing the layout and the functionality of it. And next, we'll be going over the Swift programming language, so the necessary syntax that you'll need to know in order to write code. And finally, kind of like an app example for you guys to kind of see all of that in practice. So an app design and code showcase. So let's go into an introduction to iOS app dev. To start off, iOS app dev happens within the Apple ecosystem. So if you guys know or have any Apple devices, some examples are Macs, iPhones, iPods, and iPads. So these are kind of some main devices that you guys can basically make an app for. Macs are a little bit different, but mainly iPhones, iPods, and iPads are going to be the places where you're going to be making your mobile app, right? So basically, iOS app development is going to be developing an app within this ecosystem. And this is done in two main programming languages. So the first one is going to be Swift, and the second one is going to be Objective-C. Objective-C is a little bit older, and the newly adopted language by Apple itself is Swift. And for this, like two main reasons. The first one is going to be because Swift is like about 2.6 times faster than Objective-C, as well as having a much simpler syntax. So it's like a lot more readable and easier to code in than Objective-C. So if you guys have kind of familiarity with languages such as Python or like Java, Swift is a little bit easier to learn like those. And you'll see when I go over the code that there's some noticeable similarities between them. Objective-C is a little more complicated, like C++ and some other languages. So on top of being more readable, it's also a lot faster. So that's why we're using Swift instead of Objective-C. And furthermore, just like if you guys know that Python is a lot slower than C++, well, if Python was a lot faster, you think it would be used a lot more, right? So here, this is basically the case. Swift is just like analogous to Python. It's a lot faster than Objective-C, which is made in like similar to C++. So you guys can kind of get the idea. It has a much easier syntax to use, and it's also faster. So it's obviously better, right? So next is the hardware required to kind of do iOS app development. So the hardware required, unfortunately, there's like a barrier in which you have to have a Mac computer in order to run iOS app dev software. And basically, this is because you need to have the Xcode application installed on your computer in order to kind of develop your app. So there is that restriction. But yeah, you also need the Mac operating system, just assuming you have a Mac. So why learn iOS app development? Well, over time, iOS iPhones and other mobile devices have gained a much larger market share over time. So as you can see kind of in the graph over here, since 2007, when the first iPhone was released until up to like year 2020, the amount of iPhone users has been growing exponentially. And like the numbers don't lie, right? There's been a large amount of people that have been using iPhones, and all these people are going to be influenced by what we're making. So iPhones have a large, over 50% market share of mobile devices. So that's why it's so essential to kind of learn like what people are moving towards, right? On top of that, iOS app development is different than your traditional problem solving. Like if you guys know something like LeetCode, where you guys are solving like coding problems with like data structures and algorithms, it's not like that because you're going to be also incorporating design on top of the logic that you have to use to solve the problem. And you're not just purely designing something for like an interface or a website. You're also going to be like incorporating the logic as well. So it's kind of hand in hand. Both aspects, design and logic, are used in iOS app development. So it's a good creative outlet for you guys. Furthermore, it makes use of Apple software and hardware to kind of make your app more memory efficient. So like, for example, if you guys have like a newer Mac with like Apple Silicon, then it can run faster, things like that. And finally, iOS app licensing is also used. So for example, you guys know like how before Xbox and Microsoft mainly had the game Halo specific geared towards their company. And like if you guys like have a PS4, you guys played Bloodborne before maybe. These are kind of specific to those companies who licensed the apps for themselves. So iOS app licensing is kind of useful for people who want to kind of make their app specific towards a company and kind of like specialize it. So let's go over the steps in creating an app. So first off, in general, we're going to be kind of identifying a central theme, right? So you need to identify a problem that you want to solve, as well as some kind of solution that you can create. So this is basically the brainstorming step. So identify a topic that you're interested in, and then try to think about like a solution that you could create for it. And so in general, that's kind of what we're trying to do first. And once you've been able to do that, then is a step of kind of designing your app, right? So this is where the UI and the UX, like user interface, user experience comes in. Classic piece of paper and pencil, you can do a lot. You can kind of just draw it out, design what it looks like and what you kind of envision. And also, you can also use online tools like Canva. So this is what I recommend. You can kind of just use their system and be able to implement like kind of built-in pictures and stuff like that. So it helps your imagination and like planning on where you want everything laid out. So after we've designed your app, it's kind of time to actually make it, right? So this is where this is a step where we're going to develop and test out the app. So we're going to write the code necessary to implement all the features. And also we're going to have to test, right? So we don't want users who create their iOS app to publish in the App Store. And then they find out like in the user review that they got one star rating because some person ran the app and they got some bug inside it or an error, and then the app didn't work, right? We don't want that. So that's why it's really important to test it out repeatedly. And we want to avoid these issues altogether. So that's why I'm emphasizing to test before you move on to the fourth step. The fourth step is going to be publishing on the App Store. So once you basically built it out and designed it, it's all kind of there on your computer, then it's there for, you can kind of release it for everyone else to use, right? And while you're doing so, it's important to not just leave it, but you also have to continuously add to it, update it, and make sure that it's like fresh for everyone to be using, right? You don't want an outdated app. If I make an app, like let's say I made an app way back in like 2009, right? Then you can imagine that it'd be pretty outdated if I never touched it again until now. If I just left it there all these years and now it's like 2022, well, you can imagine that people wouldn't be satisfied with what it looks like, what it does, things like that. And there's probably going to be better apps out there that other people would rather use. So it's really important to continuously update your UI UX based on the feedback that you're getting, and also to that means that you have to continuously write code for your app and make sure that it's running okay, and it's having the features you want to update over time. So these are kind of the generic steps in creating an app that you guys should keep in mind. And yeah, so let's go into Xcode, which is the IDE that you're going to be using to write your code. It's the environment where you're going to be developing your app, basically. So Xcode is going to allow us to design our app, like we said. So designing the UI UX components for your application. It's all in one. It also is going to allow you to write code. So developing it and debugging it for your application. So this is essential to when you're kind of just figuring out the logic behind your app on top of designing it. And lastly, a really important component of this IDE is that also allows source control. So if you guys know like GitHub or other applications that allow you to collaborate with other developers and develop an app. Usually an app is not developed by a singular person. That's way too much work for a single person to handle. But if you have like multiple developers who want to work together on it, handling source control is really easy using Xcode. So that's why these three features combined make it like a really good IDE. And this is the IDE that you're going to be using to develop your apps. There's not really another application that's going to let you make an iOS app. It's geared towards Apple. The app itself is made by Apple. So that's why it's so essential for you guys to know in order to basically build your iOS application. So this is just kind of like a look on what the IDE looks like. And I guess I can show you guys quick what the IDE is like other than the slideshow here. So can you guys see the Xcode? Can someone confirm?
You can see it. You can see it.
Yeah, okay. So this is the Xcode IDE here. So just supposing that you made an app and we're going to be using the Swift programming language, this is kind of the look that we're going to get. So I'll briefly go over the layout of where everything is and where you can find everything, because I know that compared to some other IDEs like Visual Studio Code, this might look a little more complicated, and it certainly is. So on the left-hand side over here, we have the kind of file system, just like in any other application. So don't worry about these sections. These are just places where you can test it. Like I said in the previous slide, you can test your app and stuff like that. And that's kind of built in over here, but we don't have to worry about that. So this is kind of like a fresh project, by the way. So in your file system, you're going to have your app, and there's going to be a couple main component files that are always here when you make your app. So the first is main, which is basically a storyboard file. And this is where your design is going to be happening. So you can see that we have a iPhone here, and it's formerly called a view controller. And this is basically where you're going to be adding all your icons and buttons and just designing your app overall. So if I want to like add something, for example, I just have to press plus, and then I can kind of just drag and drop wherever I want the stuff. So this is like a button, I can add it, I can change the text and kind of change the settings over here. So like if I want to change the text or like title, for example, I just come over here, I can double click the button and I can change it to like click me, something like that, right? So I have this button over here, and you can see that this is kind of the title that I just added. So what this right panel is, it's basically focusing on what you are working on at the moment, and it's going to show you the attributes of what you're working on. So an attribute might be click me, another attribute might be the color of the button, the size of it, stuff like that. So this is the panel on the right is basically going to be where you're going to kind of access and change the attributes of what you're trying to add on to your application here. So let me just delete this button. But yeah, that's basically where you're going to be changing everything. And this is the left panel and right panel explained. So on top of that, you're gonna have like a view controller, which is where all the code is going to go. So on top of designing, like I said earlier, you have a creative outlet to kind of write the code for your application. And this is what this is for. So your code mainly will go in like view controller. This is like kind of your main file if you want to think about it that way. And this is where all your code is going to be written for your application that's going to connect with your view controller over here. So this is where like basically again where you're going to write your code. And scene delegate and app delegate, don't worry too much about these. This is for now. This is just basically where you're going to be like using your other modules and stuff like that. So if you want to eventually have like a database or something connected to your application, you might be editing these, but for basic use, we'll just ignore that for now. So this is kind of the layout of Xcode and what each file is kind of representing. And of course, you can create many new files, but this is just the basics of where everything is. And there's also this one more component. So if you think that this is like a little complicated over here, and like if you add like a bunch of buttons and stuff on top of each other, and you don't see like where is what, like if you have a lot of overlap and like it gets pretty confusing once you have a lot of stuff built in, right? So over here, you're basically going to have a simpler version, like a skeleton of what is happening within your app. So this is your view controller scene. This is everything that you're going to be able to see. And here is this specific view controller itself. Again, this iPhone specifically over here on the screen is representing the view controller. And within this view controller, you have a view, which is basically everything that's on this screen, as well as a safe area. So you guys know on like an iPhone, because you have like a notch over here at the top, sometimes like content can get cut off. So for example, you might have like an iPhone 6 or something that doesn't have this notch and therefore has more screen space at the top. But you might also have like an iPhone 13, which has a notch at the top, and as well as this home button at the bottom. So it gets confusing on like if my content gets blocked, what am I going to do, right? So this is kind of the safe area to avoid that problem. And this is basically the skeleton of what your iOS view controller here is going to look like. And again, if I like add a button here, for example, it's going to go under the view. It's part of the controller over here now that I added it onto the iPhone, right? So that's kind of the layout of Xcode broken down. And as well, if you run code, it will show up over here, like whatever is being outputted. And yeah, that's basically the layout of what Xcode is. Yeah, basically this is just what I showed earlier. So the places where you're going to have all your stuff written out, your code over here, and the view controller earlier. And when you run the app, you're also going to have a view controller that shows basically the simulation of what your code is doing. So just a quick demonstration of that. If I'm going to try to run this application over here, I just have to press play and it will open up the simulator over here. And if I want to stop the simulator, all I have to do is press stop over here. And yeah, that's basically what those buttons do. It's really simple. Whereas like sometimes if you're writing like code in text editor, you might have to go to like your terminal and start typing in commands in order to run the code. Over here, you just have to press the play and stop button. So it's pretty simple to run your code. And I'll tell you like if there's an error somewhere, I'll mark it in red and stuff like that. So that's basically how that works. And over here, supposing that everything runs fine, we're going to get a view controller over here that's basically showing the simulation of our app. So this is where the app is going to run. And supposing I had all the stuff added on here, like a button, for example, I'd be able to see it here and start like interacting with it, right? So that's basically how you run an app and what that looks like. So with that being said, we've gone over the kind of looks and functionality and layout of Xcode. So now let's look into the Swift programming language, which is basically what we need to know in order to write code in this IDE and kind of create functionality, right? So let's go over the code demonstration. So I'll be just using an online editor here to kind of showcase the code. You guys can just keep in mind that you guys can also just write the code and like kind of view controller over here, make it function. Also, you can create some like different files, a Swift file specifically, because this is Swift programming language. So if you just create any Swift file like over here, I'm just choosing the language of Swift, I can write Swift code. So if I want to print something in Swift, all I have to do is I'm creating a comment, by the way. So I put 2 slashes in front of what I want to write code for. Then I'm just making a comment that's basically not going to execute. It's just for the whoever is writing the code to use. So I want to print something. As you can see, like from when I said that Python is really similar to Swift, then you can just do something like print hello. And this is the same syntax as Python. We're just going to print, and whatever is inside the quotation marks is going to get printed out. So next is going to be variables. So variables in Swift are a little bit different than other languages in that there's kind of different ways to make variables in Swift, which is why it's like a special language. So to start off, you can make a variable just like variable A, let's say, is equal to 2. And this is going to set the value of 2 equal to A. And similar, you can do like variable B is equal to 3. And then we can print out what A plus B is equal to, right? And if you just think about it, just 2 plus 3 will be 5. So just running this code quick. It's going to print hello first because that's what we showed earlier, and it's going to print 5 after that. So next, as I said earlier, Swift has special a special way of demonstrating the way that your variable is. So what I mean by that is I can create a variable num, and I can not choose to assign a value directly to it at that time because I might not know what type of value it is, right? So let's say, like, for example, I'm writing code and I want to, like, for a grocery store, let's say, and I'm making like a food option that like this is like kind of like the cash register, and like if I have like the grocery clerk clicking a specific food, they might have like different data types for kind of what the customer is buying. So like, for example, a customer might be buying like, let's say an apple. So they might buy an apple and they might have like different quantities, and like for the apple itself, you might like have a string like apple times 3 to signify like you're buying 3 apples. Well, that kind of data type is complicated to use, and like basically you might not know what kind of data. Basically, what I'm trying to get at is you might not know what type of data type you want to assign to a variable originally, or like what value it is originally. So I can just say variable num, I can write a colon, and I can write the data type that I'm like planning to use later on. So in this case, I can just say num is going to be an integer, but I don't know what the value of that is. Or like if this can represent, again, with the apple example, like how many apples does the person want to buy, then I can just write int over here because I don't know what how many apples they want to buy yet. And then later I could say like num is equal to like 5. I can assign a value later on without having to write var again. And again, if I just print out num, I'm going to get the same result of 5. So as you can see over here, 5. And yeah, these are basically how variables work. I can also create other data type variables. So for example, I can create a name variable and I can call it, make it a string data type. And if I do know the value, you can still say equal to, and I can just say Brian, for example, for myself. And if I print the name, it'll print the string a variable over here, as you can see. So yeah, this is basically the idea of variables here. And these are just used to keep track of data throughout your program. And next is conditional statements. So here, conditional statements, you want to are really essential because if you ever want to kind of control like what happens in your program, you need them. So like, for example, a person might want to make a different decision based on certain conditions. For example, let's say someone's taking like their app, their phone, and they want to like take an Uber somewhere, right? So if the Uber's cost is like too expensive and they might not want to use that car specifically, they might want to use like a different person. They might want to go with a different person, something like that, or use a different application. So kind of if statements are like considering different conditions, what do I want to do? So let's look at this again. So we originally assigned the value of a to equal 2. So if a is, we can say if a is greater than 0, then we can say print a is positive. So this just means like if a is greater than 0, then obviously we know that's positive, right? This is just one condition. So this is the condition here. So the format is going to be if a condition that you want to test, if this is true, then you want to perform a specific action. Else if, so I know that other programming languages like Python might have like elif, like ELIF. So in Swift, it's elif, and you're going to like just write a secondary condition here. If a is equal to 0 itself, then we can print a is equal to 0 simply right here. And lastly, of course, we can also create other conditions. If a is greater than 100, well, this wouldn't execute because a is greater than 0. It already run through here. If we could say like if a is equal to -1, for example, then print a is equal to -1. And like basically we can go on and on with an infinite amount of else if conditions. And lastly, if none of these conditions execute, we could just do an else statement, which is going to execute like if none of these other ones execute. And we just like print a is less than -1, right? So these are basically conditional statements. So you can apply these to anything. You can apply these to variables. So for example, I could say if name, like if I'm doing like a user check to like kind of do like a login, for example, I could say like if name is equal to Brian over here, which is what I set over here, then I'm going to just print logged in. So in reality, when you're writing code inside your IDE, for example, you're going to have like more complicated variables and do some more actions over here with your code. But basically, this is the generic idea of like what an if statement is designed to do. So next is loops. So as in any other programming language, we have a traditional for and while loops. So the way you write them in Swift is for I in like your starting point. So let's say 1. And you're going to write ... which means 2. So between 1 and whatever's on the other end of the 3 dots is going to be basically where it stops, right? So let's say we're using B here. So for I in 1 to B, let's say print I. So what's going to happen here, I'll run the code, is that it prints 1, 2, and 3. So what's happening here is it's saying for every number I inside the range 1 all the way up to B, which is 3, we're going to print I. So that's why it's going to print 1, and then I is going to become 2. You're going to print that out. And lastly, we're going to print out 3 over here, right? So that's what the loops is designed to do. It can kind of perform code, repeated code without having to overcomplicate too much. You don't have to write manually like print 1, print 2. We don't have to do that, right? So another way that we can use like for loops and like kind of loops in general, sorry, is to use a while loop. So we could say while a is greater than 0, print a, and then we have to subtract 1 from a. So we just do like a minus equals 1. Swift doesn't have like an a minus minus. If you guys are familiar with C++ or Java, it doesn't have like an a plus plus either. It only has minus equals like that. So that's why we basically need to be able to just minus equal 1 here. So if you guys remember, originally a equal 2. So what's going to happen here is it's going to check this condition while a is greater than 0. Is this true? Originally it is. So it's going to print 2. It's going to subtract a. So a is going to become 1. Then it's going to check again. If a is 1 now, is a still greater than 0? Yes, it is. So it's going to print 1. It's going to subtract it to 0, and then it's going to break out this while loop. So that's basically what's happening behind the scenes here. So with while loops, and next is functions. So functions, we can, these are really useful because you can just basically get rid of, let's say I want to specify a set of instructions for something like waking up, like my morning routine, right? I don't want to kind of think about it step by step over and over again. Like I don't want to think like every time I wake up, I don't want to kind of think in my mind, oh, I need to first make my bed, go to brush my teeth, and then go eat something, and then come back upstairs and like prepare my backpack for school. I don't want to think about all this stuff over time, right? So it'd be a lot easier if I could just say more like perform my morning routine and just automatically do it. So to do that, we have functions which are going to increase readability of code and kind of make it less redundant. So if I want to make a function, I can just say func, and then the name of the function. So let's say you want to add 2 numbers, for example. I can create kind of just this function over here, add, and then in parentheses are going to be the parameters that you're going to put out. So let's say num1 is going to be an integer data type. You have to specify the data type that you want to assign to this variable parameter here. And that's the first one. Let's say num2 is going to be another integer. And then after that, outside the parentheses, like you might think that, oh, normally like in C++, for example, you might have the return type, like what your function is returning in front of the function name over here. But in this case, in Swift, you have to write an arrow, which is made up of a dash and an arrow. And then this is kind of the return type, and you have to specify like what it's returning. So in this case, we want to return an integer. So that's why I'm writing that. And then the curly brace, which is going to signify like where all the function code is going to be written. So we have a question to the chat. Are function parameters final? So yeah, function parameters are final. So once you specify them over here, you can't change them over time inside the function itself. You can't like add new parameters or delete them over time. They'll just be there, but you can definitely like choose not to use, like you could choose which ones you like actually end up using, or like how much each affects the code. So these are the parameters like where you're just changing like the functionality of your code based on like what parameters are there. Let me know if that answers your question. I can definitely explain like more if you want me to. So this is basically the function. All right, sounds good. Okay, so this is our add function over here. And if we want to kind of perform what we originally planned, we can just say like return num1 plus num2, and I'll just this function will just basically return the result of that. And if I want to run this function, for example, I could just say something like variable like sum is equal to, let's say it's an integer data type, because that's what the function is returning. I can set this equal to add like 2 comma 3, for example, 2 comma 4, let's say, and that's going to return 6 for this sum, because what's happening behind the scenes is I'm calling the function, so num1 is going to get assigned to 2, num2 is going to get assigned to 4, and then it's going to return 2 plus 4 over here, which is 6. So this whole expression over here is just basically equal to 6, and that's going to get assigned to this variable over here, which is an integer data type. So that's what's happening behind the scenes here. And also, like, I recommend you guys like write the variable that it's getting assigned to, so it's kind of more readable. So I can write like num1 or num2, and I write like a colon to signify specifically what each parameter is representing. So I want to print this sum again, I can just do this. And I expect 2 and 4 to run and give me 6. For some reason, it's not running. Not sure why. Might be lag, I'm not sure, but basically, that's basically what's happening behind the scenes. 2 and 4 are basically getting added together in this function, and the return type is being stored over here in this variable. Let me delete like this stuff up here so it's like more organized. Make sure like to have like a code file at the end for you guys to kind of reference the Swift programming language and any syntax that you might forget. Let me just try it now. I don't know. Lost connection. It seems to be a Wi-Fi issue. Sorry about that. I think it's like a Wi-Fi issue or like a website issue, but basically that's what's happening behind the scenes right now. So next is classes. So we finished classes over here. So we finished functions, sorry. And now let's go into classes. So as I mentioned earlier, kind of Swift is connected to both concepts from Java, Python, and stuff like that. So these are object-oriented languages, which means that they're implementing concepts from creating an object, right? So an object is basically anything that you can define over here in code as like a specific like object that you can think. It's literally what it means. It's an object in mind. So we can create a superhero object, which we represent with a class. And inside this class, we can kind of define like what does a superhero have? Well, you can say variable name is equal to like a string data type, and we just set it originally to like an empty string because we don't know in general what a superhero's name is. There's no generic superhero name, right? So we can also create an age of integer data type and set it equal to 0 originally. You just have to specify a value over here. And also we can create other types of variables. So let's say can fly is like a Boolean, let's say it's false. And finally, we can say variable damage, the amount of damage that a superhero can do. So you guys ever creating like a video game or something, that you guys can kind of create these objects for like superheroes and like kind of create their damage and equal to 0.0. So doubles are basically decimals and Booleans are true or false values. So when you want to initialize a superhero, you write something like init. And this is basically a keyword in Swift that's going to let you kind of define like where everything is going to like set the attributes for all these values of your objects. So like let's say n is a string, a is an integer. I'm just creating shorthand like acronyms for the letter over here. So for simplicity, so CF, bool, and D double. So these are basically the values you're going to read in when you're creating an object, and it's going to assign all these variables into the attributes that we set for the class. So we just have to say like name is equal to n, and then you can say age is equal to a, can fly is equal to CF, and finally damage is equal to D, right? So then we can also create like functionality for a object. So a superhero is able to perform actions, right? It's able to walk, it's able to kind of like fly around, use their superpowers. So I can say like func use superpower. And this is just like the same thing as when I was showing functions earlier. We're basically showing what a superhero can do. So we're saying something like func superpower, and we can say like print do the amount of damage. So we're going to put like a slash parentheses to show like we're trying to implement a variable inside this string over here. And we're just going to say damage after that. So we're going to do this amount of damage using the superpower. This is basically allowing the superhero to do something specific, right? And this is our class structure. So every superhero that we design in the future is going to be able to have all these attributes over here be able to be created with these values that a user implements, and also do a certain amount of damage. So this is kind of our structure of our superhero here. If I want to like create a superhero, a specific superhero, not just have a structure, but actually create one, I can say, I can store it in a variable. So let's say variable Bob, colon to represent what type of data it is. So superhero, and we're gonna set it equal to, sorry, I'm making typos. Superhero here. And we have to, again, initialize what each value is going to be at. So the name of the superhero, let's call it Bob. A is going to be like, let's say 20. Can fly is going to be, let's say true, so Bob can fly. And D, the amount of damage that they do is going to be like 106.2, let's say, for example. And this is going to be our superhero that has this structure. And every superhero is going to be able to access their superpowers. So we could say something like Bob.use superpower. And we can also say like something like print Bob is, again, we're using a variable, so Bob.age. So these are attributes, and you can access them by saying the variable name dot whatever the attribute name is, and you're going to be able to print that out. Years old, and basically this is going to print out Bob is, in this case, we define it to be 20, so print Bob is 20 years old. Let me check if this is running properly now. I'm not sure. Oh, this is because I defined the function earlier. Oh, I could show that now. So earlier there was like a connection error, so I couldn't run the code, but right now it seems like it's working fine. So let me redefine that function quick. Num2 is going to be another integer. And it's going to return num1 plus num2. So again, like what I showed earlier, I'm not sure why exactly there was like a network error for the website for why I couldn't run the code, but now it seems to be working fine. So again, if I want to print num1 plus num2, it would print 6. And over here, after I define my class, keep in mind the class itself doesn't do anything. It's just a structure that I can use in the future. So after I define Bob over here with these attributes, once I call Bob.use superpower, we originally defined damage to be 106.2. So here in this class is going to do 106.2 damage. So that's why it's printing this out. And once I assign age to be 20 over here for Bob, then it's going to come and assign it over here. And I can say Bob is 20 years old. So is this going to print Bob is over here, Bob the age is 20 and then years old. So these are basically objects that we can use, and they're really useful for whenever you like want to make games or kind of anything in general, like a structure. These are essential. And lastly, for our introduction to Swift, there's more syntax stuff, but these are kind of the basics. Yeah, you can also define constants in Swift. So the way you do that, instead of saying var, is to use let. And the let keyword is going to make it so that the variable cannot be changed. So if I say like let a is equal to like an integer data type and I set it equal to 2, well, I can't change that in the future. This is going to be staying constant throughout your entire code. So constants are also useful, and thanks for asking that question. Constants are going to be non-changing variables. So if, like, for example, if I'm at like a grocery store, using that example again, I have like a tax rate. Well, I don't want that tax rate to change. So I can just say like let tax rate, which is like a double variable, for example, double type, and I can set it equal to like 9.8 or whatever the tax rate is. And these are basically just constants, as you mentioned. Can you also create initial constants for classes that you define initial values that cannot be changed later? I believe you can. Let me see. Define initial values that cannot be changed later. Could you clarify the question, sorry, or like just let me read it for a second? I think the way you would do that is like in the future, if you're just like trying to make a class, you could kind of like make these variables private, if you know, in like another language, and making them private will make them like non-accessible to the user, so they can't be changed. If that answers your question, but yeah, that's basically like what I'm thinking that you're trying to say, or like Another way you could try out is like just replacing these with let, I guess, but it's kind of, it'll be like kind of weird in the code, but yeah, it's basically how you could kind of make the like definitions, your attributes over here constant for the user, if that answers your question. Okay, so last part of kind of the Swift language, I guess, is arrays that I'll show you. So arrays are basically places where you can store things. So variable array, it's equal to 1, 2, 3, let's say. So the way you create an array is with these square brackets over here, and everything that's inside the array, inside the square brackets, is an item inside the array, separated by a comma to signify that each thing is like a unique item. So this is obviously many applications for this. I might want to store like all the, like, let's say I have like an application and I want to store like all the users inside like an array, so I can kind of reference their names, right? So I can print out like the names of all my users that are using our application. Well, I might want to store them inside like an array, for example. So if I want to print the numbers inside the array, I can say for num in array, and then basically just as I was writing a for loop earlier, it's not here anymore, but for each like number in range like 1 to 3, for example, I could have printed it out. And there's another way to write a for loop. So for each object num inside the array, I can print out num. And you could change this num to anything you want to. You can call it anything you want. So I can say like number, or I can call it x, or whatever I want. I just have to reference it over here. So it's going to check every object inside the array. I can print it out. So if I run it again, I'm going to get 1, 2, and 3 because it's going to go through this array and it's going to print every value in there. And another way I can do this again is with that original for loop that I showed. So I could say for I in 0 dot 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 array.count -1. So array.count is going to be like the length of the array. So in case it's going to be 3. And you could just print array at index I. So this is kind of, you just put the square brackets over here to signify like which index you want to print out from the array. And that's basically how you're going to access information arrays. So this is kind of an introduction to the Swift syntax and the programming language itself. So this is what we're going to be coding in kind of in the Swift programming language. So this is an introduction so you guys can understand code and like kind of reference, like understand what's happening behind the scenes. And that's basically a Swift programming language. So I know it's a lot to take in, but really a lot about coding is kind of taking your time and kind of experimenting by yourself, getting comfortable with the language and kind of just testing it out, because I know that a lot of this might look complicated at first sight. So once you guys like kind of get used to the syntax, it might take a couple days, might take a week, but eventually you guys will get comfortable with the syntax such that you guys can start coding on your own. So this is an introduction to Swift. And finally, let's take a look at an app example. So this is kind of an app that I made, like a demo beta version of an app that I made in the past called TeacherLink. So here you guys can see that from something as simple as a blank screen on a view controller and kind of your files, you can kind of design everything out and kind of create like a navigation system. So I have like a back button that you guys might have, like if you guys have an iPhone, creating several attributes for kind of like entering login information, create a place where like a user can type something, a login button, and then like an image over here. And you can see that things get really complicated really quickly. So you might have like multiple screens inside your application. So you might want to change your screen. So each of these sections over here, let me like draw it out so you guys can see. So each of these is kind of representing its own screen. So over here, like for example, this is a login page, right? So this is only referencing this section of the view controller. So this is the view controller for the login section. And you can see that I have a place for them to write their email, like a text field, so the user can enter text, which is going there. Let me clean this up again so you guys can see. So email text field is coming over here. This is the section that we're working with. The password, which is over here, is being referenced here. The graduation cap, this is basically the kind of like all the structure, the skeleton, the bare bones of what your app is made up of. And then kind of the login button over here. And this is going to just basically be like the layout of the app. And every screen has, of course, their own attributes. It could get even more complicated than this, but this is just basically the structure of the app. And of course, as I said earlier, you can kind of change the attributes of like, what color do I want to make this button? You could change it throughout over here, like the background color, stuff like that, right? So this is the layout of that screen specifically. And this is the showing the overall structure of the entire application, which has multiple view controllers, which I'll show you in the next slide. So again, like I said, you can have like multiple view controllers, and this is basically when you're wanting to change your screen. So again, let me draw it out. So these are basically individual view controllers, different screens of your iPhone. And like if you click something, then it might go to a different page, for example, or like if I click back, it might go back to this other page. So it gets really complicated quickly. And this is to again show like a simplified structure of where everything is. So you might have like a view controller, the original one, a place to log in, view your classes, a place to chat, a register, et cetera, et cetera. So these are all individual places where you can kind of show what's being put and where. And again, as I showed earlier, like when I open Xcode, I have this plus button in the top corner. And when I click that, I have all the different types of things I can add on to my iOS application, right? So I might want to add a label that just shows like, tells a user to put something, so just like a piece of text. I can add a button for users to do something. So I might have like this plus button here, being able to kind of add something over here. And I might have like different type of buttons, et cetera, et cetera. There's many, many, many more objects that I can use. I can show you here. If I go through the list, there's too many to go over. Clear my drawings. So if I click this plus button, you can see that there are a ton of things that you can implement to your iOS application. These are all built in by Apple for you guys to use and explore. And there's just so much to learn over here in iOS app development. And these are basically all the components that we can have onto our application, right? So basically over here, we're able to see kind of in our main.storyboard file, what's happening, what are all the places that we're having information and kind of layout being designed. And on the back end, we also have code being written to kind of create functionality. We're not only designing an application in iOS, we're also writing code to give it functionality, right? So this is basically like some basic code being written out. So we have importing some modules and kind of having some variables here. And when a specific button is pressed, then we want to perform this action. And kind of we're just checking. Some of this code might look familiar to you from what I said earlier, but basically this is where we're kind of controlling what's happening throughout the application. So for example, let's say I want to click this back button and might want to go to the previous view controller. So and you have to manually write that out throughout your code in order to perform all the actions, specify what exactly happens for each action that you do. So this is kind of like the file structure of the system. So again, if I want to make like an assignment, for example, that I defined here, over here, I'm showing like a bunch of assignments and like kind of a list. So I can create like a structure for that. So you can either use struct or assignment, but I just use the struct. It has the same functionality basically as a class. And as you can see, like earlier when you were asking about like the initial constants for classes from Scrappy, that question that you had earlier, here's an example of that. So you can say let the name of the class be a string data type, assignment name to be a string data type, and the due date to be a string data type. So this is just defining a class that we can kind of use later on. So this is kind of the code, and you can of course reference this code in other files as well. So this is what's happening in Swift over here. And I'll just do like a quick demonstration for you guys to be able to see something that's implementing code and the design as well. So just something really simple, but nevertheless, something that you guys can kind of see. So let me just create a button here and let's call it click me to perform an action. So I'm doing this, I'm creating a button over here. Of course, I can start like changing the color and stuff like that, but I'll just keep it simple for now. So I just have a regular button over here. It doesn't look too fancy or anything. And let's say I want to do something when the button happens, right? So the code, as I said, the main is going to be where I am basically creating like the design of my app, right? This is where everything is going to be stored. And in view controller is going to be where I'm writing the code in order to basically perform the functionality of the app that's being designed over here. So on Xcode, you have this really nice way of having both the design as well as the code have side by side, so that you guys can kind of reference, go back and forth, because it might be like difficult to change screens and like stuff like that. So in order to solve that issue, there's a way that you guys can split screen by clicking this top right button over here. So you have the iPhone on the left, and you can have the view controller or the code over here on the right side, right? So this is a way to be able to kind of have both your design and code at the same time, so that it's easy to kind of see and envision everything that's happening. Structs and class, they both have similar functionality. Classes just basically have like more features involved in them. But yeah, basically they have like really similar functionality, and sometimes it can like basically be interchangeable. Yeah, and they basically like same thing. Structs can also have methods, as I demonstrated in the code earlier, just like how classes can kind of have, if you remember the superhero code, I can like make a superhero be able to use their superpower. Likewise, I can use the struct. They're really, really similar. But overall, like I said, they're kind of like almost interchangeable. And like basically, as I was saying earlier, basically, I have this button that I made in design. If I want to perform an action when this button is designed, I'm going to hold down the control key on my Mac, and I'm going to drag the button onto the code over here. And you can see how like nice the user interface the Xcode is made for. I can create interaction between the design and the code. It's not just writing code in order to solve a problem, and it's not just designing something and making it look nice. It's a combination of both. So I can call this like click button action, and this is a type of connection it is. So an outlet is basically like a variable or like a reference. An action is a place where you can perform an action when the button gets clicked, for example. So type is going to be a UI button. This is just basically a button. And these are just things you don't have to really worry about for now, but basically we're just creating an action when this button gets pressed. So if I press connect, you can see that I have a new kind of function over here, an IB action that's a function, and it's going to perform when you have a sender here. Ignore this. It's going to perform when you have a sender here, which is the UI button. And then whatever code is going to be written out over here with these curly braces is going to be executed when this button gets clicked by the sender, which is the UI button. So let's say this button did get clicked. I can print something like hello in the console, right? Hello, this button got pressed. So we're creating interaction between the design of the application as well as the code that's being written. So if I press run again, let's letting it build, and you can see that build succeeded. And now we can come into our simulator over here. And if I click me to perform action, well, we come back over here and we can see that we've successfully created interaction between both the view controller as well as the code. So when this button got pressed by us from this, it called this function. It says when this sender, which is the UI button, this UI button is the sender, and it's sending a message to this function, this code over here, saying this button got pressed. And then it's performing the action of whatever is inside the curly braces. It's printing this button got pressed. So that's why it's going to print something over here. So this is basically how we're going to create interactions between code and the user and the design. So when you can imagine that this is useful when you're doing something a lot more complicated, like any button you press in a game. Now that you guys know what's happening behind the scenes, whenever you guys are playing a game, clicking a button, you can imagine all the code that's being run behind the scenes and all the actions and all the functions that are being run to do all the actions that the game requires in order to run properly, right? So you can see how amazing all that is. Are there tools like linters available for Swift? I'm not familiar. Could you explain what linters is to me? Formats your code and enforces rules. Yeah, I think there's definitely like there's definitely built-in ones, and I think like prettier. Okay. So I kind of get the question, I guess. Formatting your code, yeah, there's like specific keyboard shortcuts, I guess, and like modules you can install onto Xcode that are like kind of built in, and they're basically going to help you guys to kind of format them. And also like Xcode is really flexible about like showing you where like everything goes wrong, like kind of indent stuff for you too. There's keyboard shortcuts that you guys can kind of research later on if you guys are interested about like kind of formatting your code properly. But like Xcode does most of the work. If I have like a syntax error, like a variable, like a is like let's say it's like a string data type, is start like setting equal to 3, for example, like Xcode will like it'll make like really big warning messages. Like over here, you could see that like cannot convert type into string. Like it's pretty instant. It shows you exactly where the error messages are, and they won't go away. It's not like a text editor where like you kind of have to run the code to see where your errors are. Xcode will literally just highlight wherever your code is going wrong, like immediately as soon as it sees it. So it'll be right there for you guys to see. If it doesn't satisfy you enough, there's like, again, like I said, probably like modules and stuff built in that you can download and things like that, so that you guys can have more functionality into Xcode for this type of stuff. But yeah, as you can see, Xcode does like most of the work for you. It's really responsive to everything you write. And I'll also want to mention, if I ever just close the application, everything is saved. So you don't have to manually press Control S or save. Everything is saved by default. So you guys don't have to worry about like, oh no, I write my code and all of a sudden it disappeared because I forgot to save the file. So now all my work is gone. You guys never have to worry about that because Xcode always saves your data and all your code that you written out automatically. So yeah, this is basically an introduction to iOS app development in Xcode. Over here, you can see another example. So this is a little more complicated, but I'm basically creating like an assignment, which is going to store like a list of assignments over here with different attributes. So if you guys remember, over here, I create an assignment structure with these different attributes, like a class name, assignment name, and a due date. And over here, I can kind of assign variables over here. So different classes that a person might take, their assignment name and like their due date, and I can store these as like an assignment data type, basically an object. And I'm going to store all these object assignments inside a list, and I can kind of print them out later on. But yeah, basically, this is the structure and layout of Xcode, how you develop an iOS application, create interaction between both the design aspect and the coding aspect of computer science for app development, specifically in the iOS environment. So with that being said, here are some extra resources that I've linked over here that you guys can use to reference and learn more about app development from this workshop. And these are basically good references you can use and the places to start on where you guys can learn the necessary skills to develop your own iOS application. But for now, thank you everyone for coming to our workshop. I hope you guys learned something new and enjoyed what you guys saw today. If you guys have any questions, be sure to ask, and I'll be here to explain you guys any questions you have. But other than that, thank you everyone for coming. We'll be sure to post this workshop on YouTube, just like our other workshops and events over here at EcoHacks 2022, and we'll post them online for you guys to reference. So this is always here for you guys to reference and see. And thank you, everyone. Is it possible to use generics templates in Swift? Yeah, there's definitely templates online for you guys to kind of see like how other people are building specific structures, and you guys can kind of use them as reference when you're writing your own code and see what you like and don't like and kind of specialize it to your own application. Thank you so much, everyone.
All right, bye guys. Thanks, Brian, for an amazing presentation. All right, see you guys.